Right, so this first problem, I think we went over this in class, but it was really quick, so yeah, we'll do it again. Write the standard form of the equation, which has the x and y intercepts of the equation y equals 4x over 9 minus 8 switched. Don't include spaces when writing the equation. All right, so just to start us off here, we want the line with the x and y intercept switched, and I immediately see, since this line is in slope intercept form, that the old y-intercept is -8. And then to find the x-intercept, you set this y on the left hand to 0, since the x-intercept is where it intersects the x-axis, so then y would be 0. So we have 4x over 9 minus 8 is equal to 0, so x is equal to 18, you get, right? So given that the x-intercept is 18, the y-intercept is -8, then you want to find the line which has these intercepts switched. Now does anybody want to step in and explain how they would go from here to find the line? Just raise your hand or anything if you want to. Right, so I don't see anyone, so I'll just continue. Okay, so, okay. So the first step I would do is, the x and y intercept. So I would find like the equation of this new line in slope intercept form first, and then I would find the standard form from that. Okay, so we know it passes through 0, 18, and then -8, 0, since the intercepts are switched. So then the slope of this line is 18 minus 0 over 0 minus -8, which is equal to 9/4 if you simplify that. So then it's just equal to, y is equal to 9x over 4 plus 18. And yeah, you can check that both of these x and y intercepts lie on that line. Okay, so from here, I'll just finish it. You multiply by 4 to get 4y equals 9x plus 72. And then you move this to that side, this to this side to get in standard form. Wait. Is my screen share still? I think my screen share just cut off by accident. Sorry. Alright, anyways, as I was saying, then you have y equals 9/4 x plus 18. When you multiply by 4 on both sides, you get 4y equals 9x plus 72. So then you move the y term on the same side as the x, and then you move the constant term to the other side to get 9x minus 4y is equal to -72 as the final answer for the equation of the line. And yeah, that's basically all for this problem. Just ignore the standard form at first and just use slope intercept form in the equation you're given to find the line first, and then convert it at the very end. And that's the best way to, because like it's just not easy to do it otherwise. Yeah, that's all for this. Okay. So the next problem is a bit different. We have for integral coordinates x and y selected such that 0 is less than or equal to x is less than or equal to y is less than or equal to 5. And they want to find how many distinct values of m or slope are possible if the graph of the equation passes through the point xy, and xy is in that range, something like this. Whoops, right, yeah, it's a pretty bad drawing, but or now, does anybody have any ideas on, or any like ways or things they notice about how to count the number of distinct values of the slope? You can just raise your hand or chat if you have any ideas. Right. Looks like no one much has it and has any ideas, so I'll just go over this. So you know that the slope of this line has to be like, since it goes through one of these points with integer coordinates, it has to like, whoops, it has to like, the slope has to be a rational number fraction. So just like if the line went through 1, 2, then the slope would be 2 over 1. Yeah. All right, so knowing that, we also know that x is less than or equal to y is less than or equal to 5. So then this fraction, you must be able to express it with like a numerator over that's less than or equal to 5 over a denominator that's less than or equal to 5. And furthermore, you're also given that x is less than or equal to y. So that means since x is less than or equal to y over x is greater than or equal to 1. So then the slope of this line must be bigger than or equal to 1. That being said, you can just do casework on the denominator of the fraction. Since the denominator can only be from 1 to 5 anyway, then in simplest form, the bound is still 1 to 5 for the denominator. So if the denominator is just 1, then the slope is an integer, which gives 1, 2, 3, 4, 5 as possible slopes. And those correspond to like these lines, or no, sorry, this drawing is like really bad. It's not drawn to scale. Yeah, those correspond to those lines as I drew right there. And then if the denominator is 2, meaning like the point, this point has x coordinate is either 2 or 4, can be, then you have, not counting like 2 and 4 and 2 and 1 and 2 and things like that, then you have that the slopes can be 3 halves and 5 halves. Because you want the number has to be relatively prime, because you want 2 to be like the lowest the denominator when the fraction's in simplest form, and then it can't be anything bigger than 3 and 5, since if you check the constraints, anything bigger would fall outside y is less than or equal to 5. All right, and then for denominator of 3, then you have that the slopes can be 4/3 and 5/3, passing through the points 3, 4, for lines passing through the points 3, 4, and 3, 5. And yeah, the same thing here. It can't, when the denominator is 3, it can only be these since the slope is bigger than or equal to 1, and it has to be less than or equal to 5 in the numerator. But yeah, just make sure that you're like checking that these are actually possible or attainable values along the way. And then lastly, you have 5/4 when the slope is 4, or when the point that it passes through is 4, 5. All right. And yeah, when the denominator is 5, there's nothing really, because it can only be 5 over 5, and that's just 1. You already counted that. And that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slopes. Should be the right answer. You may also notice that like there's a vertical line that passes through like these points, but like that isn't really a value of slope, that's like undefined, so we're not counting that in this problem. So wait, so this problem actually didn't touch upon like a key concept of slopes and equations of lines. It was more about like reasoning what it can be based on the bounds they give you, as well as like the least denominator. Yeah. So anyways, moving on to systems of equations. A system of equations is a set of multiple equations that represent the relationships between multiple variables. For example, you might have the equations a plus b is 9, and then 3a plus 4b is 32. And you can solve the system of two equations in two variables in a couple of different ways, namely substitution and elimination, and we'll go over that. So for substitution, substitution is simple. You just plug an expression for a variable into an equation. One example, see if you have x is 2i plus 4 and y is equal to 3, you'd substitute 3 for y and get x is equal to 2 times 3 plus 4 is equal to 10. And I'm pretty sure you can all see why, because like y, x is equal to 2y plus 4, and then you're just directly given that y is the same as 3, so then you can just plug in 3 for y and get x is 10. This is the most basic form of substitution. Another way is you isolate a variable in an equation. Let's say 2x plus y is equal to 9 as they show here. Then you move the 2x to the other, you subtract 2x from both sides, and then you get y is equal to 9 minus 2x. And now if you had like another equation, like I don't know, x plus y is equal to 5, then what you do is you take this expression, since it's equal to y, you plug it in, you get x plus 9 minus 2x is equal to 5, and then you get to solve for x is equal to 4, I believe. And yeah, that's how that works. Substituting a variable in terms of another variable. Oftentimes, there's more than one choice for what to substitute, but just substitute the thing that's the most convenient. Like, try not to bring in like fractions or a lot of those, a lot of nasty things. And then if you substitute, you solve for one variable, like I said, and then you, like I wrote on the side with this example, and then once you get x, you can just plug it back in here, and then you get y is equal to 1, I think, if you use that example. Anyways, yeah. And now for an example to see if you understand this, or two examples. What's the value of x when in y equals 2x minus 4 when y is equal to 7? And then solve for x and y in this system of equations. This one is just like more basic substitution, like what we talked about here, up here. While this one is, you have to substitute one variable in terms of another, and then I'll give you a couple minutes to work on these, and once you're done, you can just DM me your answer. And yeah, if you have any questions, you can ask me or the TA, as I said before. Right, so I see most people already got these, so I'll just go over it. Or actually, does anybody want to go over how they did it, since I saw a lot of people do it right? Or yeah, Leo, go ahead for the first one.
So y is 7, so we put that in the equation, so we get 7 equals 2x minus 4. Then you add 4 to both sides to get 11 equals 2x, and now you just divide by 2.
Yeah, and so the answer should be 5.5 or 11 halves. Either way is fine. Or 5.5. And yeah, that's it. You just plug in y in here, since like it's just simple. You see y is equal to 7, and you plug it in where y shows up, and you solve for it. Now, does anybody want to take the second problem? Or yeah, Vincent, go ahead.
Using the second equation, we get y equals x plus 5. Substituting, you get 2x minus x minus 5 equals 4. Simplifying, you get x equals 9. Plugging back into the second equation, you get y equals 14.
Yeah, that's right. So x is 9 if y equals 14. For these, you can very easily just check that they. Oh, my screen share keeps cutting out for some reason. I'm not sure why but sorry about that. But I think you got the steps that he walked me through. Anyway, so you can easily just plug in these values you get back into these equations and check that 2 times 9 is equal to 18. 18 minus 14 is equal to 4. And then, of course, 14 minus 9 is equal to 5. And yeah, that's just to quickly check. And yeah, just like Vincent did it perfectly. You write y in terms of x, y is equal to x plus 5. And then you plug it in for y in this equation. And then you get x minus 5 is equal to 4. Be careful to like distribute this negative sign to both the x and the negative 5. Sometimes you can like make that mistake and write x plus 5 is equal to 4, but yeah, no. It's x minus 5 is equal to 4. And then you get, yeah, x is equal to 9 and y equals 14. And like I said, you can just plug it in to check if you're not sure or if you don't think it's right. Okay. So yeah, that's basically how substitution works. These are pretty like simple examples, so we'll move on to more. So the next thing we're going to talk about is elimination. This time you try to eliminate a variable from the system by adding or subtracting equations. And the basic concept can be shown by this example. If 2x plus 5y is negative 4 and 3x minus 5y is 19, what is x? And I'll let all of you work on this. And as a hint, you see a 5 and a negative 5 in this problem, and those two numbers cancel when you add them. And yeah, after you're done, you can just send me your answer for your value of x. I'll give everybody like a minute. All right, so I see a lot of answers. All of them have been right so far. And so now I'll just go over it. And just as a reminder, I didn't see this happen now, but earlier I saw some people send their answers to everybody. So yeah, and just make sure to send it privately so as not to like accidentally reveal things. But yeah, I'll go over this. Does anybody want to show how they like did the elimination? Yeah, sure. I wait. Was Jerry raising his hand, or I guess not anymore. So I'll just let Vincent take this again.
Adding the two equations, you get 5x equals 15. Dividing by 5 on both sides, you get x equals 3.
And yeah, that's right. Going with the hint, you just add these two equations because then the y term becomes 0. You just get 5x on the left side with the variables, and then 15 is 19 minus 4. So then yeah, you get x is equal to 3. Of course, you can just plug it in really quickly to find 3 times 3 minus 5y is equal to 19. You can solve for that. Y is equal to negative 2. And yeah, that's basic elimination. Most equations you can solve with elimination, but you have to take an extra step. Like you have to multiply one of the equations by a constant factor to get the coefficients to like match, or to match so that when you add or subtract the two equations, then it'll just directly cancel. Oops. All right. So on to our next example. Solving systems with elimination, and like I said, you'll need to manipulate the equations often to make coefficients match so you can add or subtract and eliminate one variable. And for this problem, this example, we have 3 chocolate bars and 5 lollipops cost $3.70, while 4 chocolate bars and 2 lollipops cost $3.30. And you want to find out how much will it cost to buy one of each. Right, so first I'll just write down our equations here. 3c plus 5l is equal to 3.7. Then we have 4c plus 2l is equal to 3.3. And then I'll give everybody a couple minutes to solve this one. And as always, just send me your answer when you're done. I'll check it. All right, so I'll go over these now. I see Jerry raising his hand, so Jerry, do you want to unmute and go through like solving these
Sure,
with
I guess.
elimination?
So first, we typically multiply the 3c plus 5l equals 3.7 by 2, and the second equation by 5. So then you get 6c plus 10l equals to 7.4, and what is it? 20c plus 10l equals to 16.5. So then if you subtract the second equation from the first equation, you get 14.9. And yeah, 14c equals to, 14c equals to 91 cents, I think. Yeah, 9.1, and then I just multiply by 10, which is 91 over 140, and then you do and then you do and then it's 13 over 20, which is 0.65 cent, which is 65 cents. And you plug it into the equations, so then you get that the lollipop is 35 cents.
Yeah, that's right. For this one, numbers are pretty like small, and you can just do it either way, multiplying the first one by 2, the second one by 5, or the first one by 4 and the second one by 3, which is how I did it to verify really quick. And either way, you should end up getting L is 0.35, C 0.65. He did it right. You get both of these to 10, and you subtract this from that, then you get 14C is 9.1, and that's basically it gives you C. Plug this back into either one of these, and this one is I think 1.95 plus 5L, I think it's a 3.7, and then you get 5L is equal to 1.75, from which you get L is equal to 0.35, and yeah, that's right. Someone also mentioned that you can subtract the equations to get like, you can subtract the equations I think to get like C plus L first, and then use a substitution with that, and that would also work well. Although I still think this is the most straightforward way to go about substitution for this problem. And so yeah, the chocolate costs 65 cents, and the lollipops cost 35 cents. Next thing is just a very quick thing, is that systems of equations of two variables are tied to lines, in that linear equation can be represented by a line. Like if you have, in our previous problem, I think it was 3c plus 5l is equal to 3.7. If you say maybe like the L is the y-axis variable, C is the x-axis variable, you have 5y equals negative 3x was 3.7, then you just see, oh, this is the form of a line. So then yeah, it's just that you can do and then yeah, you just write it in slope. You can just write it in slope intercept form, and then that's just the graph of a line. And then the other equation would be similarly be like 4x plus 2y is equal to 3.3. That's another line, and where they intersect would be the point then 0.65, 0.35, I believe. And to like view it on this graph, of course, these aren't the same equations, but yeah, these lines represent equations. And to like think about it a bit geometrically, the intersection point is their solution. So at this point, the x and y coordinate correspond to the x and y variables that make up the solution. There's always, for systems of equations of two variables, linear equations with two variables, there's always going to be one solution, infinite solutions, or no solutions. And those happen, one solution happens very typically, like these two lines have totally different slope and everything, and they just intersect in this one point. If they have no solutions, that's when the two equations lines are parallel, like something like this, because then the parallel lines never touch, so then there's no solution. To quickly think about what kind of system would give that. If you have like x plus y equals 1 and x plus y equals 2, you notice that like you get 1 equals 2, so that's not possible. There are no solutions to this system. And if you look at it, they both have slope of -1, and so yeah, and they have different y-intercepts, so that's why they don't intersect. And of course, the exception to this is like if these are the same, then this is always true, and so the lines are the same, and there are infinitely many solutions. But very typically, you have just one solution to a linear system of two equations and two variables, and if you graph their lines, then geometrically the solution is represented by their intersection point. Yeah. You don't really need to like, I guess, know that too much because it's not like ancestral information. You can deduce whether or not there's a solution by the equations themselves. And so now we'll just go over some system of equations practices. I'll give you a while for these. For this first one, Kelly and Jason are going out for a run. Kelly leaves 2 minutes before Jason. If Kelly runs 7 miles an hour and Jason runs at 9 miles per hour, how long will it take Jason to catch up for Kelly? For this one, I recommend you set variables for like their distance or their time taken, and then I'd go with time, but you can do either way. And yeah, just set up equations. Make sure you know how to use this condition, this 2 minutes before, and then to find when they catch up, then they'll have traveled the same distance. And so yeah, based on that, you can set up their equations and solve it. Similar for the age one, just like set the variables to be the people's ages, and then just write the equations based on the information you're given, and then solve for it. And so yeah, I'll give you several minutes for these two problems. And overall, today we'll just be doing quite a bit of practice on like word problems that can be solved with systems of equations for the next couple of slides. So yeah. And as always, privately send me your answer once you're done. Alright, so first I'll go over number one. I saw several people did that. Does anybody want to show how they did number one? You can just raise your hand if you want to do a question. Alright, nope, I guess no one. So I'll just go over number one myself. So let's say that Jason has I'll solve for how long Jason has been running, since like it's from his perspective how much time he takes. So I think it makes sense for the answer to the question to be how long he has been running when he catches up. So I'll have a variable j is equal to Jason's time, and then of course we have k is Kelly's time. And then we have Kelly leaves 2 minutes before Jason, so that means she's been running for 2 minutes longer no matter what point in time they're at. So we have k is equal to j plus 2. Now at the point at which Jason's caught up with her, they've traveled the same distance. So that means 7k is equal to 9j. And then at this point we just substitute k is equal to j plus 2. So we get 7 times j plus 2 is equal to 9j. And alright, I almost forgot, this 2 is in minutes while these rates are in hours, so it should actually be 1/30th of an hour. So you have 7j plus 7 over 30 is equal to 9j, from which we get 2j is equal to 7/30th, j is equal to 7 over 60. So after 7 minutes, 7 minutes of him running, Jason will have caught up to Kelly. And so that's how you do this problem. And if you get 9 minutes, you probably just did what I said, like you did the amount of time passed out from Jason's perspective. But yeah, and that's all for this problem. I see a lot of people are also starting to get number 2 as well. So does anybody want to do number 2? Again, you can just raise your hand if you want to do. I guess nobody for number 2 either, so then I'll just go for that. Well, you should volunteer if you have a solution, since like I see a lot of you are getting this correct, so you can just share your approach. But anyways, so we have P is Pamela's age right now. We have, say, T is Thomas's age. Today Pamela is 4 times as old as Thomas, so P is equal to 4T. In 8 years, Pamela will only be twice as old, so then 8 years should be P plus 8 years old. In 8 years, Thomas will be T plus 8 years old. And so we have this equation from this condition. Yes, I'm not very good at drawing these lines. From this condition, we get the second equation. Now you want to find how many years from now will Pamela be 3 times as old. Also, we have P equals 4T. We substitute 4T in. Or yeah, I guess you can just subtract these two equations to eliminate. So I'll just do it this way to practice both ways. So we have P plus 8 minus P. 8 is equal to, let's see, negative 2T plus than 16. So then 2T is equal to 8, and then T is equal to 4. P, plugging it back into here, is equal to 16. Alright, so now I want to see how many years from now Pamela will be 3 times as old as Thomas. And then, yeah, I see someone said they kind of just did a little guess and check, but it's definitely better to solve this for sure using all these variables. And so now we have Pamela's current age, Thomas's current age. We want to see how many years from now will Pamela be 3 times as old. So let's say after k years this happens. So then Pamela will be 16 plus k at the time. Thomas will be 4 plus k, and we know 16 plus k is equal to 3 times 4 plus k, because 3 times as old. Alright, So then we can just solve for k here. 16 plus k is equal to 12 plus 2k. I mean 3k. And then we get 2k is equal to 4 and k is equal to 2. So in 2 years, Pamela will be 3 times as old as Thomas. So you can just really quickly check this. 16 4 times 4. Yeah. In 2 years, Pamela will be how much? 18. Thomas will be 6. And yeah, 18 is equal to 3 times 6 as well. In 8 years, Pamela will be 24 and Thomas will be 12. 24 over 12 is equal to 2. So everything is right in this problem. So yeah, just for these age problems, just define variables as their ages and then translate the sentence into an equation involving those ages. And then you plug in, you can substitute or eliminate to solve. And that's how you do that problem. For the first problem with Kelly and Jason, yeah, you can either you can either use the variables as like their times or as their distances, or in other problems, not in this one because they give you their speeds. You might want to set the speed as well. So yeah, that's all there is to these. So again, we'll be just doing practices for now for a while. And then there are two more. These are a bit more difficult. Uh, the first one, Jason takes 20 minutes to travel 1 mile upstream, but he takes just 7.5 when traveling downstream. And you want to find what's his speed in still water. And this is and like as you might be able to see from the context, this is assuming that the water he is in like flows at a constant rate, like I don't know, W or something. You can set it to whatever you want. So then, and it also assumes that his raw speed, um, let's say like maybe S is the same for both this 7.5 minutes downstream and 20 minutes upstream. So just to be clear, then that would mean his upstream speed would be his raw speed minus the water speed, and then his downstream speed would be his raw speed plus the water speed. And using this, they want you to find how much how fast he is in still water, which means that he's only going at S. And I hope that's clear for everybody how to like, I guess, set up this problem. For the second problem, just to give a hint on this one, okay, so a cycling shop has bicycles and tricycles only. So you know that that the total amount of vehicles, I guess, totals to mm, the sum of the amount of bicycles plus tricycles. And now, if a shop currently has 42 cycles and a total of 90 wheels, and how many tricycles does the shop have? As you probably know, a bicycle contributes 2 wheels to this total, and then tricycles contribute 3 wheels to this total. We know there are 42 vehicles in total, and they have a total of 90 wheels. And so yeah, that should be enough to help you solve both of these problems. So yeah, you can just go ahead and solve them, private and estimate your answer when you're done. Right, so I see most people are getting these, so I'll go over them. I'll go over number two first since I see most people got them, and yeah, I think it's actually this one's actually easier in my opinion. So we have cycling shop, and it has bicycles and tricycles, and yeah, does anybody want to go over their approach for this one? You can just raise your hand if you want to go over it. All right, yeah, Vincent, go ahead.
So the question is the two equations that you get from these words are 2x plus or 2b plus 3t equals 90 and b plus t equals 42. So plugging in you get multiplying this equation by 2 you get 2b plus 2t equals 84, so t equals 6. So the number of tricycles is 6.
Yeah, that's right. You can solve this using substitution as well, but yeah, elimination works just as good. And so yeah, the key to this is that each vehicle contributes. If it's a bicycle, 2 wheels. If it's a tricycle, 3 wheels. So then that gives this equation, and then this equation comes from the total amount of things is, um, yeah, 42. And then like Vincent did, you multiply the second equation by 2, and so that matches the b terms coefficient, and then you subtract them to get t is equal to 6. So the shop has 6 tricycles. Make sure to answer the right question for this one. If you want to do it with elimination, you can just do like b. Wow, yeah, that was not well written. You can do b is equal to 42 minus t, and you do like 2 times 42 minus t plus 3t is equal to 90. So then you have t plus 84 is equal to 90, and then you just get the same thing all over again. And so yeah, that's how you do this problem. And now I'll go on to number 1 in just a minute. Alright, so now I'll go over number 1. So number 1, Jason takes 20 minutes to travel 1 mile upstream, but he takes just 7.5 when traveling downstream. What's his speed in still water? Okay, so for this one, does anybody want to do this problem? Alright, no volunteers. A lot of people solved it though, so yeah, if you want to show your solution, you should definitely should. I'll do this one. So we have Jason's speed that we want to solve. His still water speed, let's say, is J. And then we have the water speed as, say, W. And now I think a lot of people did this as well. Looking at these numbers, 20 minutes is 1/3 of an hour. 7.5 minutes, if you think about it, is 1/8 of an hour. So then using distance equals rate times time, the first one gives 1/3 times J minus W is equal to 1, since we know upstream is like this, he's going against the current. And similarly, 1/8 times J plus W is equal to 1. Yeah. And then there are a few ways you can go from here. You can just, I think the easiest way is just directly adding them. Get 1/3 plus 1/8. J is equal to 2. And then, yeah, that should get 1/3 plus 1/8 J is equal to 2. Yeah, that should get you the answer of like 11 over 24 J is equal to 2. And then, wait, let me just check this for a second. I think, yeah, I don't think this is right. Oops, so yeah, this is not so let me just check what I did wrong here. So these equations are right, so then you can just, all right, you can't just add them like that because they're different. So, and my screens are just cut out, sorry about that. I'm not sure why that keeps happening, probably connection issues. Anyways, going back to this, we have to get into a form where you can just like cancel them. You have j minus w is equal to 3, j plus w is equal to 8, and then you can just add these two j is equal to 11, and j is equal to 11 halves. And remember, this is in miles per hour. I noticed a lot of you actually caught that it was in a different unit, although for this problem, since they give it in minutes, I'd say just write your final answer in minutes anyway, so that would be 11 over 120 miles per min. And yeah, that's how you solve this problem. Although I do agree that converting it to hours makes it a lot more convenient because like you don't have all those coefficients that you have to get rid of. But yeah, that's how you did this. Is speed and still, you have the variables as speed and still water, since it's like it's easier to reason everything and reason all of its speeds in relation to that. And the water speed to account for, and then you build two equations from given the amount of time it takes to travel the same distance in both downstream and upstream, and that gives you your answer. All right, so we're reaching, there are a few more examples, but I might just lump those in with homework. Well, for now, I'll just quickly go over three sessions of three equations and three variables. So the way you solve these is you have that there this system of three variables, three equations, it's linear again. And the way you tackle this is you try to get rid of one variable first. Like let's say you want to get rid of z, maybe. So then you want to get two equations with x and y. So you take these two and then you get rid of z and you get something with x and y from them. What I mean is like you have x plus 2y plus 4z is equal to 7. And you multiply this one by 2, you get 4x plus 10y minus 4z is equal to like 30. Add those and you get 5x plus 12y is equal to 37. This is just elimination again. You'll probably know that. And you do the same, you can do the same thing with like, let's say this one and this one. And it doesn't matter which two pairs you pick to get like these equations or like which variable you choose to eliminate first. As long as you pick like two different pairs, since then you're making use of all three equations. So for this one, you multiply this one by 2, 6x. Wait, my pen is not working. I think, right, there we go. 6. Wait, sorry, my pen does not seem to be working right now. Right, so I'll just write. Sorry about this. My pen just isn't working. So I'll just type 6x plus 4y plus wait, no, sorry about that. I'm getting my pen changed. Sorry about that. Sorry, I don't know. Yeah, so now I'll get rid of it. And then we have 6x plus 4y plus 2z is equal to 8. And then we add this to that. And that gives us 8x plus 9y, I believe. Is that right? Yeah, is equal to 23. And then you can just, and so this is just a system of equations in two variables, and we know how to deal with these. We can solve for both x and y from just these two equations. And then we can plug those back into any one of these three to get z again. And that's how you solve this equation, or this system of three equations and three variables. And yeah, if you aren't clear on that, it's not a problem. And we've reached the end of our lesson today. Here's here's some extra practice problems you might want to look at that I might add to the homework. But yeah, and if I do assign this one for the homework, it's okay if you don't get it since we didn't really go over it in class. Well, you can look back on the lecture to see what I discussed about it. But yeah, that's about the end of the lesson. So yeah, thank you all for coming, and yeah, that's it.
Thanks, bye.